Hello everyone, welcome to the channel. In this video, we're gonna see about the simple attention mechanism without the weight parameters. It is the first principle, weight parameters using the attention mechanism. Mm, Without the attention mechanism, with using simple attention mechanism to calculate the word embedding into the contextual embedding. It is a simple steps. We need to understand how the matrix are working. How does the context will capture between the similarity search. It is a very simple concept before we are going to the self-attention layer. It is we we are we are before we're going to the transformer architecture. We should know about the self-attention. If we want know about the self-attention, we need to study about first principle of attention mechanism without trainable parameter. It's very simple and easy to understand. Let's start the journey. First thing, first need to calculate the attention for the single word. It's a very important thing. First, we need to static embedding. It's mean we in every sentence the word embedding doesn't change. It means, for example, the bag is very lightweight to carry. It's a different contextual meaning. The room is very full of lights. It's different the contextual meaning. But in a static embedding, it means word to wake or glow. It means it's providing the contextual. It's not providing the contextual embedding. It means it's providing the um, um, static embedding. It's just same value doesn't change in a based on the context. So we need to change the static embedding into the contextual embedding. There are the four steps to change the static embedding to the contextual embedding. First step, phase one, the static embedding. Second phase, the attention source will be calculated. Next phase is attention weight will be calculated. Last thing, the contextual embedding will be get. So let's start the process. First, I have the three-dimension vector. Why I should that take the three-dimension vector? It is easy to visualize and easy to understand in the diagram. Let's see here the diagram in the three dimensions. So I will take the three dimension for the example to understanding easy. In a real life, it will be the many dimension like 520 for the ChatGPT 3. It contains the 520 dimension per token embedding. Let's start the process. First thing, we have the embedding of query. It means it is a light. So the agenda of the diagram will find to the contextual embedding of light. It's a very simple thing. Um, first, first we need to calculate the attention score. The attention score base calculated on the matrix multiplications in vector multiplications. So I have the static embedding of the every tokens in the sentence. The in a three dimension room is full of lights. I have the all the um, static embedding vectors. Same as well as I have the light. So I will multiply. Transpose them each query vectors. First thing, it will be the light and multiply with the vectors. It's mean we element wise operation it's occurred in this process like that. It's 0.5 multiply into 0.1. 0.1 multiply into 0.2 and 0.3 is multiply into 0.3. It's mean the outputs of scalar value. So the similarly we calculate the S1, S11, S12, S13, S14 and S15 same as was S16. It is a scalar values. We need to understand in operation of matrix applications, it will be the in vector to vector, its answer will be in the scalar value. We need to calculate the phase 2, the attention score. The attention score, it's these are the attention score. It's 0.16 is the attention score. We need to calculate the attention weights. We need to attention weights. It's mean we need to normalize the value. It's mean you give the probability to the every words to attention in the each word. We using the softmax activation function. It is a popular activation function during the multi-class classification in the different task. So the S1, first we need to calculate the S1. We need to the exponential of S11 multiply into the remaining of um, word scalar value. So it is a formula of the softmax activation function. So finally we calculate the W11, W12, W13, W14, W15, W16. So the final step is very simple. These are the weight attention weights. We need to calculate the contextual embedding. It's very simple. First thing, we have the attention weight, and we have the values. So it will be multiply into the attention weights in the each query vectors. So it's multiply into the room is full of light. So it will be the process of changing into contextual embedding. So the multiply the each value, it's then we added the overall vectors. It's mean the multiplication of them, the multiplication of room, the multiplication of is and full of light to adding the every vector into the single contextual vector. So we need to understand here three dimension. The output will also a three dimension. See the diagram. It is the overall contextual of the whole sentence. So we trying to understand the in the coding session. First need to understand the diagram. It is a light. It's a different contextual. The um, embedding vector. This separate embedding vector. It's a separating vector. In this stage, the every vector doesn't know about the another vector information. So it is not contain the contextual values, not capture the contextual. In the diagram, after the applying each words, similar like kind of this, we have in a similar vector direction and magnitude. So the every word capture the each and every tokens. It means the contain the information about room, the room contain the information about is, the rooms contain information about the full. So the contextual will keep adding on the each and every tokens. The similar as well as these these values also. Let's go to the token. I hope you will understand this concept. If you will not understand, please comment in the below section. I will reply on as soon as possible. Next thing we into the code. It is a code sample code of the attention mechanism. I use a torch for the multi-dimensional values. It is the first token. It's the went to the bank to deposit the money. It is a different context. Next, the token 2, it will be the they picnic on the riverbank. So the context of every words will be differ from the sentence. So here the bank, here the bank, but different meaning. So see here the token embedding also same while we are using the static embedding. It is a bank of embedding. The 6,6,6, 0,6,6 and 0,6 is also a second embedding. It is a static embedding. So we need to plot that with a simple plotting in a Python. I took a matplotlib and 3D plot and separate the tokens, and I have the every token embedding in a three dimensions. It help to visualize simple in easy way. See, it is an important thing. Let's see in the see here. Um, the see here is a very important thing. So it is deposit two and another words are separating here. One thing here, the bank is overlapping here. It means the vectors are same, so that the banking meaning does not change based on the context. It is a very important thing we need to understand before moving to the self attentions. It is also capturing the importance. It is a first principle. Don't. It is a very simple attention mechanism. So it is not changing the large data sets. So we need to change here into somewhere here based on the context. So let's go to the code again. um here here go to the I am the modular coding. It's a very simpler coding. We need to calculate the contextual embedding. Here one second. um Here let's start here. Here we need to understand very easy. It's a batch of data. Here um same as well as here. Beautiful. Okay, I see here. Okay, let's start about the. Okay, okay, it's easy now. Okay. See here. First thing, I use a torch for the multi-dimension vector. Here, it is a second contextual embedding word. It is a embedding word captured the meaning on the static embedding. First, I'm creating a class contextual calculation. It's a very simple. I'm so we want to the static embedding. First thing we need to calculate the attention score and then calculating the attention weight. Finally, we get the contextual values of each sentence. First, the sentence we have the three dimension of each word vectors. So in this we have stored into the word embedding for the each word of in the sentence. Next, attention score. It is a very simpler way to calculating the matrix multiplications in the batch of data. We have the data in each and every token in the sentence, and we need to transpose. The transpose working on the tensor only, and multi-dimension it can be work. And we have the attention score. Then putting the attention score into the attention weight. Here the process will happen. The matrix multiplication then happen into the softmax activation function. So we get the each and every um, value in the 6 of vectors. It will be 6 for the one vectors. So it attention weight calculated the based on 6 value using the softmax activation function. Next we get the 6 comma 6 value, 6 cross 6 values matrix. Then we calculating the easier way, which will be calculating. We have the same attention weights in 6 comma 6 rows, activating the multiplication wise operator to look like that. The attention matrix of the each after the come from software and overall overall tokens. So the tokens will be there is room for flights and each attention weights. So we calculate that easier in the contextual values. So let's go the um, code in a experimental way. So import the contextual calculation. I put the contextual token for first here over there. So I am first take the contextual embedding of first sentence. I take it over here and put it over here. Then I calculating the attention score. This will be attention score like that. I will show it that also. Attention score here. See, here the attention score. So attention score calculated here. We have attention score. We need to calculate it with the help of attention score, the attention weight. So put the attention score based on the attention module. Mm, I put it over here, then calculating the attention weight in this manner. I see. I also show it the um here like that. Then we calculate the contextual embedding. It means the weight. Put it over here, and just multiplication of operations happen in the every matrix. It's look like that. So I have the two sentence. I'm show it over here. First token, its meaning. She went to the bank to the deposit the money. They picnic on the river bank. So here, see before the contextual, the overlapping here. After the contextual, see here. So bank here, the another bank over here based on the context. So it will be keep on the changing on contextual based on the static embedding. It is a power of attention mechanism. It's very powerful in the modern world of artificial intelligence. So it is have the problem. It's not a fully functionable self-attention. It is a not trainable parameter. It's a problem when we are using in the trainable parameter. Let's we see about that also. Here, see over here, we have no parameters over here. So first, if you know about the deep learning, the parameters are using to the learning parameters. The model, the learning parameters learn from the huge amount of data. So that variable parameters are need to train the contextual meaning of from the static embedding. So in this problem of first principle of attention mechanism, it's very simple. Just just a multiplication over another tokens embedding, just calculating. Then normalizations, it's using softmax normalizations. Next, using adding the weight and added over the multiple stack of vectors, and it's keep the same dimension of contextual embedding. It's a very simple. So after the contextual embedding, use the vector will down over here, the each and every vectors down over here, and keep the meaning of another vectors. So it's a very very important thing you know need to before learning the self attentions. Just learning something new here before going to the self attentions. It is easy to understand the self attention layer before you learning this. So I provide the Jupyter notebook link in this video below. If you have any doubt in the video, please comment over here. I will answer as soon as possible. Okay. Thank you for the watching the video. Please subscribe and like and share the video with your friends. Thank you so much.